Okay, so I'm going to go over our chapter 6 review questions. Okay, so the first one is the word problem, and I'll put a link down below in the description so that you have a copy of this review. Okay, so a manufacturer of skis produces two models, a regular ski and a slalom ski. A set of regular skis produces a $25 profit, and a set of slalom skis produces a profit of $50. The manufacturer expects the customer demand of at least 200 pairs of the regular ski and at least 80 pairs of the slalom skis. The maximum number of pairs of skis that can be produced by this company is 400. How many of each model of skis should be produced to maximize profit? Okay. So what we want to do is we need a profit equation. Okay, so my profit will be 25x plus 50y for the regular and slalom skis. They also give me some parameters that I need to stay within. So the first one is that x has to be at least 200 and y has to be at least 80. Okay, so 200, you're going to make at least 200 regular skis and 80 slalom skis. And the total number of skis that you produce has to be less than 400. Okay, so from there, we're going to graph these three. Okay, so if I graph my 200, so let's say that's 100, that's so 200. So let's say we're here and we'll shade this way. So that's bigger than 200. Okay, and then 2, 400, 100. So this is 80 on the Y, and we'll shade this direction. Okay, and now I need to do this line right here. So we'll say Y is less than equal to negative X plus 400. So that's 400 here, and then down one, right one, all the way across to 400 here. So I'll have this line here, and then we'll shade below that. Since Y is less than my line, we shade below. And you get this region right here where everything is shaded, and that's where my possible solutions come from. So what we want to do is we want to find each one of these three ordered pairs. So this one right here will be 200, 80. This one up here, it's 200 on this line. And this green line right here represents where I have 400 pairs of skis. So it's actually 200, 200 because it adds up to 400. This one here, we know the purple line was 80, and that was Y. Again, it's on the green line that multiplies or adds to get 400, so that's 320. So then we'll take these three ordered pairs and we'll plug them back in to our profit equation to see which one gives us the bigger number. So I have 25 times 200 plus 50 times 80, which is 9,000. I have 25 times 200 plus 50 times 200, which is 15,000. And then I have 25 times 320 plus 50 times 80, which is 12,000. So right here is where I get my max profit. So we'll say max of $15,000 at 200, 200. Okay, so this is what we want our answer to be. All right, so now we'll get into solving some of the systems, which I don't tell you how to do on the review, and I won't tell you how to do it on the test either. So you kind of get to choose how you want to do it. So we have 2u plus 5v equals 7, and 3u plus 3u minus v equals 5. So we'll take this first one here, and we'll solve it for v. So negative 3u plus 5, and then v equals positive 3u minus 5. We'll take that and we will plug it back into the top equation. We'll plug it back into the top equation so that we can solve for u. So I have 2u plus 5, parentheses 3u minus 5 equals 7. So 2u plus 15u minus 25 equals 7. 17u minus 25 equals 7. 17u equals 32, and u is 32 over 17. Now that I have u, we're going to take that and plug it back in over here so that I can find v. So v is 3, 32 over 17 minus 5. And you can just plug this back into, or plug this into the calculator. Make sure you're using lots of parentheses. Let's see here. When you plug it in, use lots of parentheses. So we'll say here 3, 32 over 17 minus 5, and then we want it as a fraction in the end, so I get 11 over 17. So I want to write my answer as an ordered pair, and the reason I want to do that is because these are two lines that we're trying to see where the two lines intersect, and they happen to intersect at a point, so we write it as an ordered pair. All right, our next one, 4r minus s equals 1, 8r minus 2s equals 2. Okay, so I'll do elimination with this. So we'll take this top one, I'm going to try to eliminate r, and we'll multiply it by 2. So we'll get 8r minus 2s equals 2. And 8r minus 2s equals 2. So you notice that these two are the same. So if I was going to graph these, it might look something like this for one, and the next one would just land right on top of it. So I get 0. When I subtract here, I get 0 equals 0, which we would say is infinite solutions, but it's really not, because this solution over here doesn't work. It's any solutions that are on this line. So we still need to write our ordered pairs, but this ordered pair should be every solution on this line. So we'll let my x values, which are r, we'll let my r's be r's. Okay. So then we're going to take one of these, because they're the same, so it doesn't really matter. And since I know what r is, I need to know what s is, so I'm going to take it and solve it for s. So minus s equals minus 4r plus 1, and s equals 4r minus 1. So this here is 4r minus 1. And that's the solution we want. So every single ordered pair on this line is in this form. So if I want an ordered pair that works, we'll say we'll pick 5, and then we'll plug 5 in over here. So that's 20 minus 1 is 19. Or we could pick -1, so that's -5. We could go on forever. So it's infinite solutions on the line. But this right here is what I'm going to be looking for on the test. All right, so 8/5 x minus y equals 24 over 5. And then -4/5 x plus 1/2 y equals 3 over 2. So we don't really like, or you guys really don't like to work with fractions. So we can get rid of them by multiplying by the common denominator here. So we'll multiply that by 5 and this one by 10. So we get 8x minus 5y equals 24. And then this one, I get -8x plus 5y equals 15. So then to eliminate your x's here, we'll just add. So those cancel and those cancel, so you get 0 equals 39. And anytime you get an untrue value, it is no solutions, but it's actually no real solutions because there are probably some imaginary or complex solutions to this, but we're only looking at real solutions. All right, so we'll go to 3 variable now. So if we look here at this problem, okay, the first thing you need to notice is that it is not in order. So we need to make sure all my x, y's, and z's are lined up in columns. So we'll have negative 4x plus 3y plus 5z equals 2, and 2x minus 3y minus 2z equals minus 3, and negative 2x plus 4y plus 3z equals 1. So now that they're all lined up in columns here, we're going to take the first 2 and eliminate a variable, and we're going to take the second 2, and we have to eliminate the exact same variable. So looking here at these variables, or the coefficients on the variables, which one might be easiest to eliminate? And in this case, it will probably be our x's here. So if I take the first 2, I need to multiply the middle one here by 2. So we'll multiply the second one by 2, get 4x minus 6y minus 4z equals negative 6. Okay. And to eliminate our x's, we're just going to add. So those cancel. Get negative 3y plus z equals minus 4. So then we're going to take our second 2 equations, and we have to eliminate the same variable. So we're going to eliminate x, but I don't have to multiply by anything. So we will just add these down. So those cancel. I get y plus z equals minus 2. So I have y plus z equals negative 2. So then I need to get rid of one of these. So I'll subtract and eliminate my z's. So I get negative 4y equals negative 2. So you get y equals a half. Now that I have y being a half, we'll plug it back in to, let's say, this equation and get z. So a half plus z equals negative 2. So subtract a half. Z equals negative 5 over 2. And now that I have y and z, we'll plug it into one of these over here. Doesn't matter which one, to find out what x is. So let's say the middle one. So I have 2x minus 3 times a half minus 2 times negative 5 over 2 equals negative 3. So 2x minus 3 over 2 plus 5 equals minus 3. I like to multiply and get rid of my fraction. So 4x minus 3 plus 10 equals negative 6. 4x plus 7 equals minus 6. 4x equals minus 11. X equals negative 11 over 4. Okay, so now you have your x, y, z. We'll write it as an ordered triple. So x, y, z. And there's your ordered triple. All right, let's go to one that might be a little bit easier. So 2x plus 5y equals 9. X plus 2y minus z equals 3. Negative 3x minus 4y plus 7z equals 1. So in this top equation here, we're already missing one of my variables, z. So in this case, we'll just take the bottom 2 and get rid of whatever variable was missing. So I'll take this second equation and multiply it by 7. So I have 7x plus 14y minus 7z equals 21. And I'll leave this one alone. And then we will add these equations. So 4x plus 10y, those cancel, 22. And then I'll bring back that equation at the beginning. Okay, so I noticed that if I want to eliminate my x's, I could just divide this by 2, or I could multiply the second one by 2. It doesn't matter. So if I take this one times a half, I get 2x plus 5y equals 11. Then I subtract, cancel, cancel. 0 equals minus 2, which is false. So no real solutions. Or just no solutions is fine. All right, number 7 here. Number 7 is going to be a little tricky. So I'll have 2a minus b plus c equals 3. A minus b plus c equals 2. Negative 2a plus 2b minus 2c equals minus 4. Again, we want to cancel one variable out of everything. And notice here that a's might be easiest to cancel, so we'll multiply the middle one. Multiply the middle one by 2. So then we get 2, 2, 2, 4. So we'll take the top 2 and subtract. So that cancels. 1 minus negative 2 is b. 1 minus 2 is negative 1c. And 3 minus 4 is negative 1. Take the bottom 2, and it looks like we're going to add. So those cancel, cancel, cancel. 0 equals cancels 0. So when 0 equals 0, we talk about how there's infinite solutions, but I still need this ordered triple in this case. Okay, so this would be my A, B, and C. Now, since I don't know anything about A, we're not going to worry about that. I know B and C is right here. So what we'll do is we'll make one of these our constant or arbitrary term. So I like to make it C here. So we'll say that's C. To find B, we'll just take this and solve it for B. So B minus C equals negative 1. B equals C minus 1. So that's C minus 1. Now to find A, we'll just take these two values and plug it into this. We had this original equation right here. And we'll take and plug C and B in. So A minus C minus 1 plus C equals 2. A minus C plus 1 plus C equals 2. Cancel, cancel. A is 1. So here is your ordered triple. So this right here could be a solution. Okay, A is always 1. And then if 4 is C, then B is 1 less than C. So this could be a solution. And I might ask you for an example of a solution on the test. All right, so we're going to do number 8, which is graphing. So let me draw out a graph here. Okay, so we've got 3 equations here that we want to graph, and we'll just start with an easy one here. Y less than equal to 5. So 1, 2, 3, 4, 5. It's a solid line, horizontal, and we're going to shade below. Okay, go to another easy one. Y greater than equal to negative 1. So here's negative 1. It's a dotted line since it's not equal to. And we're going to shade above on that one. So then we have x, go to the last one there, x less than equal to 4. So 1, 2, 3, 4 on the x. Solid line. and we said x was less than equal to. So we're going to shade this way. So right now, if I were to stop, my solutions would come right in this area. We have two more equations. We'll look at x plus y greater than equal to 1. So y is greater than equal to negative x plus 1. So it's a solid line, so we'll go to plus 1, and it's got a negative slope. So down 1, right 1, down 1, right 1, up 1, left 1. And I like to go all the way until I'm touching some other lines. And it's y is greater than, this represents your line. So y is bigger than your line. So here's the y-axis, here's my line, and I just simply ask myself, where are the y values bigger than this line? Well, bigger would be above, so we'll shade this one that direction. And our last line here is y minus x less than 3. Okay, so we'll say y is less than x plus 3. It's a dotted line, so we want to make sure we're using open circles. And we have a positive slope, up 1, right 1. Or down 1, left 1. Dotted line. And y is less than my line, so we're going to shade this direction. So hopefully you can kind of see where we're shading. So we're between these lines, we're to the left of this one, we're above this and below that one. So right in here, there are my solutions right there. Infinite solutions right in there. Okay, so we want to minimize the function z equals 5x plus 7y, and then it gives us some constraints. So we're graphing again. Okay, so the first one is x is bigger than 0, so that's here, and y is also bigger than 0, so that's here. So we can actually ignore all of that stuff. We're in quadrant 1 right here. Okay, and then we have x, y. So we've got x plus y is less than equal to 3. So that's y is less than equal to negative x plus 3. So that's 1, 2, 3, 4, 5. So we're at 3. We're going to go down 1, right 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. And I'm stopping here because I only want in that quadrant. And y is less, so we'll shade this direction. And then we have negative x plus y greater than equal to 1. So that's y greater than equal to x plus 1. So we're at 1, and we're going to go up 1, right 1. So it's going to just right there. And we want x or y above that, so there. So in this case, I'm just shading this triangle right here. Okay, so I've got ordered pairs here. This is kind of like question 1. I have 3 ordered pairs here that I want to plug into this equation and see what I get. So this one right here is 0, 1. I also have 0, 3. And I also have 1, 2 that I'm plugging into this equation right here. So I've got 5 times 0 plus 7 times 1. I kind of ran out of room for my answer, but that would be 7. Here I have 5 times 0 plus 7 times 3. That's 21. And here I have 5 times 1 plus 7 times 2. So that's 14 plus 5, that's 19. Okay, so we wanted to, it said minimize. So right here is my minimum. So minimum of 7 at 0, 1. And that would be my solution for that problem. Okay, I'm actually going to stop and split this video into two parts. Okay, the first part is going to be all the new stuff in chapter 6, and the second part is going to be all the old stuff, so the back of the sheet. So here's the back of the worksheet. Again, you can print that off, the link below. Again, there's 5 true-false questions from systems, logs, imaginary numbers, parent functions, and there's 1 5-point extra credit problem. Okay, so make sure you watch the second part of this if you want all the questions on the back. As always, thanks for watching. This is at THS Mr. Jones signing off.